Hi guys, this is Vineet and I welcome you to this video. Today we will talk about sort in tempdb option for indexes in SQL Server. But before we proceed ahead, I would request you guys to please go ahead and subscribe to my channel. There is a subscribe button below this video. Click on that subscribe button. It will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding all my future videos. The reason I'm telling you to subscribe is because I'm creating more and more videos on indexing. So I don't want you to miss on any of the videos. So that's the reason I'm asking you to subscribe to my channel so that you don't miss on any of the videos. So let me give you 5 seconds to subscribe. Please go ahead and do so. So guys, I hope you must have subscribed by now. So we can move ahead. There are some points to remember while watching this video. Please watch this video till the end to gain better clarity of the concept, and if it's possible for you, please watch this video twice or as many times as you want until the concept gets clear to you. Perform any exercises in your test and lab environments. Do not touch any production environment or production databases. We would like to know your thoughts regarding our videos, so please do share your comments and suggestions. And you may also share any of your stories. We love to read your comments and stories and eagerly wait for the same as well. So do post in your comments and stories, guys. Now let's move ahead. We have created some playlists for you to watch. Some of the common playlists for SQL Server are database design, tables, business continuity, SQL Server indexing, performance tuning, integration services, transact SQL. This video pertains to the SQL Server indexing category, and we have created almost like 11 videos under this category of SQL Server indexing. We are working on creating more indexing videos these days. So stay tuned, keep subscribed if you have not. We have posted more than 230 videos on our channel. So please go ahead and watch them out. And the reason we create playlists for you is because we feel that playlists are best way to learn about any particular domain. For example, if you want to learn about SQL Server database design domain, it's better to go to the SQL Server database design playlist and watch out all the videos from starting till the end if you want to gain mastery over that area. And I have a channel page link as well. So link for all these playlists and my channel page link are given in the video description area of this video. So please check out the video description area. Now let's come back to today's topic, which is sort in tempdb option for indexes in SQL Server. This will be a theoretical topic, so let me directly take you to notes quickly. Alright, so today's topic is sort in tempdb option for indexes. So whenever we create or rebuild an index by setting the sort in tempdb option to on. So if we turn on this option sort in tempdb, if we turn this to on, and after turning this on, if we create an index or rebuild an index, we basically direct the SQL Server database engine to use tempdb to store the intermediate sort results. So otherwise the sort results do not get stored in the tempdb if we don't use this option sort in tempdb. If we use this option, and any result of creating index or rebuilding an index, any intermediate sort results will get stored in the tempdb database if this option is turned to on. And although this option increases the amount of temporary disk space, so when the data gets stored in the tempdb, it requires certain amount of disk space, right? So this option turning sort in tempdb to on requires some disk space. So this option increases the amount of temporary disk space that is used to create an index. And the option could reduce the time that is required to create and rebuild the index. So the benefit of using the sort in tempdb option is that it can create index in a faster manner. But yeah, the con is that it occupies some disk space. And basically, this option, sort in tempdb, this option could help in reducing the time that is required to create or rebuild an index when tempdb is on a set of disk different from that of a user database. And in order to reap performance benefits of using this option sort in tempdb, you need to make sure that your tempdb is allocated on separate drives other than the user database drives if you want to really reap the benefit of this option. Basically the reduction in time while creating indexes on the tables and using the sort in tempdb option. Let's talk about phases of index building. Now as the database engine builds the index, it goes through the following phases, and let's discuss on these phases. The database engine first scans the pages of the base table on which the index has to be made. So it scans the data pages of that base table to retrieve any key values, and basically it then builds an index leaf row out of that for each data row in the base table. So database engine basically creates an index leaf row for each row in the base table, and it basically this stores this particular data, which is the index leaf row data, in the internal sort buffers. When these internal sort buffers have been filled with leaf index entries, so once these internal sort buffers are filled with the leaf index entries, the entries are then sorted and then written to disk as an immediate sort run. So once your internal sort buffer gets filled up, then the sorting takes place. So the leaf index entries will get sorted and they are basically written to the disk as an immediate sort run. The next step is that the database engine then resumes the, so after sorting out the data, the database engine then resumes the database scan process once again. Once the sorting is done and data is written to the disk, then database engine goes again to the data pages of the base table and it does the scanning process once again until the sort buffers are again filled and sorting operation again takes place, and this process goes on continuously. And this basically pattern of scanning multiple data pages followed by sorting and writing a sort run continues until all the rows of the base table have been processed. So guys, this process goes on until all the rows of the base table gets consumed and they are sorted. The next step is that the database engine then merges the sorted runs of the index leaf rows. So finally, after third step, we have basically sorted runs of the index leaf rows, and basically database engine then performs the merge operation to merge all these sorted runs of index leaf rows into a single sorted stream. So database engine creates a single sorted stream out of these multiple sorted runs of index leaf rows. So once we get a single stream, the sort merge component of the database engine starts with the first page of each sort run. So basically, in order to create a single sort stream, the sort merge component of the database engine starts with the first page of the each sort run. All right, in order to get this single sorted stream. So whenever it starts with the first page of each sort run, it finds the lowest key in all the pages. So it tries to find the lowest key in all the pages and passes the leaf row to the index create component. The sort merge component of the database engine basically scan all the pages of all the sort runs to find out the lowest value in all of the pages or in all of the sort runs. And once it finds the lowest value, it passes on that leaf row to the index create component. And similarly, the next lowest key gets processed and then the next and so on. And when the last leaf index row is extracted from the sort run, so when we come to the last leaf index row, when it is extracted from the sort run page, the process shifts to the next page from the sort run. Now the next step is, as each leaf index row is passed to the index create component. All right. So during the sort merge operation, each leaf index row is passed to the index create component. The index create component, basically what it does is it basically writes new index pages using these leaf index rows data. All right. So once as each leaf index row gets passed to the index create component, the index create component basically writes new index pages is using these leaf index row data. And database engine also builds the upper level of the index as well at the same time. Each upper level index page is written when it is filled. It basically marks the upper level of particular index page, and once the page gets full, the database engine marks the upper level of the index page. Now let's talk about the sort in tempdb option. Now when this option is turned to off, so this is the option we can turn it on and turn back off. Now when this option is turned to off, which is the default thing, so by default this option is turned to off. When this option is turned to off, the sort runs are stored in the destination file group. So whatever our sort runs are during the index building process, the result of these sort runs gets stored in the destination file group instead of the tempdb database. The sort run results are stored in the destination file group. And during the first phase of creating the index, so when we are creating an index, and during the first phase of creating an index, the alternating reads of the base table and the writes of the sort runs move the disk read write heads from one area of the disk to another. So during the index building, what is the process? We have discussed it before. Basically, the database engine scans the pages, which is the read operation, and basically then create a leaf row, index leaf row, basically, which means the writing of data into certain location to create the index leaf row. So this is basically a read and write operation. So here we are discussing about that. So during the first phase of creating the index, basically the alternating reads of the base table. So during the index creation, the reads of base table gets performed, and also the writes of the sort runs, whatever is the result of sort runs. The database engine writes the result to the empty location. So this alternating reads of the base table and the writes of the sort runs move the disk read write head from one area of the disk to another. So that thing happens. The head moves from the all the read write head moves from the one area of the disk to another in order to perform the read operation, and another for the write operation. So it has to move between the read and write area continuously. Now the heads are in the data page area as the data pages are scanned. So head of the disk will be in the data page area if it is scanning the data pages. The head basically move to the area of free space when the sort buffer gets filled. So in order to write the data of the sort run, it moves to the free area and then write out the leaf index row data, or sort run result, we can say. So first the heads are in the data page area first, and at that time the data pages are being scanned, and then they move to the area of free space where the sort buffer fill, and the current sort run has to be written to the disk. All right. So it goes to a free area and write the result of the sort run in the free area. And then it again moves back to the data page, which is the read area, to scan the data pages again as the table page scan is resumed. So this is the continuous operation where your disk head moves between the data pages and the blank area to write the sort run result. Now, third point is that the read write head movement is greater in the second phase. So what is the second phase basically? In the second phase, out of these leaf index rows, the actual index gets created out of the leaf index rows. So this constitutes the second phase of index building. So the read write head, if we talk about, its movement is greater during the second phase. And at that time, what happens is, at that time, the sort process is typically alternating the reads from the each sort run. So during the second phase, what happens is, the read write head has to go to the read area to read from each sort run area, and once the read is performed, the data has to be written to the empty area. So read write head movement is greater in the second phase, and in this second phase, basically, the sort process basically typically alters a read from each sort run area, and it has to write that data into the empty area. And both the sort runs and the new index pages are built in the destination file group. So if this option is turned off, sort and tempdb option is turned off, both the sort runs and the new index pages are written to the destination file group. In the same destination file group, both the sort runs and the new index pages are written. So sort pages are already present in the destination file group, and the next step is to write the new index pages, but that writing will also happen in the same destination file group where the sort runs exist. And this means that at the same time the database engine is performing reads across the sort runs, it has to periodically jump to the index extents to write new index pages as they are getting filled. Let's talk about the scenario where this option, the sort in tempdb option, is set to on. What happens during that time? So we are taking two conditions here. When this particular option, sort in tempdb option, is set to on, and at the same time your tempdb or temporary database is on separate set of disk from the destination file group, then in that case, how the index is written, let's discuss about that process. So let's talk about the first phase where the database scan happens and leaf index entries are written or temporary sort runs are written to the disk. So let's talk about the first phase. In the first phase, the reads of data pages occur on a different disk. So here the tempdb is on a separate disk and destination file group is on a separate disk, right? And so during the first phase, the read of the data pages occur on a different disk where the destination file group is there, or the source file group we can say is there. So the data reads happened on a different disk from the writes to the sort work area in tempdb. So if this option is turned to on, your sort run information gets written to the temporary database or tempdb, which we can place on a separate disk. Alright, so during the first phase, the read to the data pages occur on a different disk. Under this scenario, when this option is turned on, during the first phase, the reads to a data pages occur on different disk from the writes to the sort work area in the tempdb. So sort work area is there in the tempdb now. This means that disk reads of data keys can continue serially. So your disk head has not to move it continuously between the read area and the write area, as the reading and writing area is different in this scenario, and the reading and writing area is on separate disk altogether, which means that disk reads of the data keys from the source table can continue more serially because the read write head has not to move to the write area for that particular disk. Reading can be more sequential or serial across the disk. And also, if we talk about writes to a tempdb disk, they are also generally serial as to the writes to build the final index. When the now let's talk about the second phase, when the immediate sort runs are stored in the tempdb. Now once the first phase is over, all your sort runs are stored within the tempdb instead of the destination file group. So when this option is turned to on, all your sort run results will get stored in the tempdb. Now let's see what happened after that. So when the immediate sort runs are stored in the tempdb instead of the destination file group, now there is more space available in the destination file group because your sort run data is stored in the tempdb instead of the destination file group. So your destination will eventually have more disk space. And basically this increases the chances that index extents will be continuous. So this increases the possibility that your index extents are not fragmented over the disk, and they will get stored in the sequential fashion as we have more space available in the destination file group. Now if a sort operation is not required, or if the sort can be performed in the memory, so database engine also check whether sort operation is required or not, or whether the sorting can be performed in the memory. If the database engine found such scenarios, it will basically sort the result in memory, and at that time the sort in tempdb option gets ignored because the database engine is sorting the results in memory. So sort in tempdb option will automatically get ignored by the database engine. Now let's talk about the disk space requirement whenever we are storing the temporary sort run data into the tempdb. So eventually we will have obviously we will have disk space requirements. Now when you set the sort in tempdb option to on, you must have sufficient free disk space available in the temp database to hold the intermediate sort run result. Alright, so we should have space available in tempdb to store the intermediate sort run result, and it should also have enough free disk space in the destination file group to hold the new index. Now new index will get created in the destination file group, but yeah, your temporary sort run result gets stored in the tempdb. So both the destination file group and the tempdb must have the sufficient disk space available. For tempdb, it must have sufficient disk space available to hold the sort runs, and for the destination group, it must have sufficient space available to store the new index. Now the create index statement fails basically if there is insufficient disk space or insufficient free space, and if there is some reason that databases cannot auto grow as well. In those cases as well, the create index statement fails if your database cannot auto grow, and also if there is not sufficient disk space on the drive to acquire more space, such as no space on the disk, or auto grow option is set to off. In both the cases, if there is no disk, or in the case auto grow option is set to off, we can get errors while executing the create index statement. If sort in tempdb is set to off, now if this option is set to off, the temporary sort run data or immediate sort run data will not get stored in the tempdb, but instead where it gets stored in the destination file group itself. So if this option is set to off, the sort in tempdb is set to off, we should make sure that sufficient available free disk space in the destination file group is there and must be required, roughly equal to the size of the final index. So the amount of space required should be equivalent to the size of the final index. In addition, we can have additional space, but yeah, at least we need a space to store the final index. During the first phase, now we are talking about the situation when the sort and tempdb is set to off. Let's talk about that. During the first phase, the sort runs are built and require about the same amount of space as the final index. So we are talking about the situation where our sort and tempdb is set to off. So in those situations, the data for temporary sort runs will get stored in the destination file group, right? So in those cases, during the first phase of the index building, the sort runs are built basically in the destination file group, and it basically require about the same amount of space as the final index. So the amount of space required is equivalent to the space required for the final index. And during the second phase, so we are talking about the first phase here, how much space is required for the first phase. So in the first phase, what happens is data gets scanned out of the data pages, or index keys get scanned out of the data pages, and temporary sort run data gets written. So at that time, we need the same amount of space as it is required for the final index. To basically store the temporary sort run, we need similar amount of space as it is required for the final index. Now during the second phase, in which the sort run result will get ultimately merged to the final index that is being created. So during the second phase, each sort run extent is freed. So once the sort run entries are read and finally the index are built, the sort run extent gets freed after it has been processed. So all the sort runs get processed one by one, and they get freed once they are processed, and the index pages are being written or created at that time. Therefore, the overall space requirement, if we talk about, do not exceed the size of the final index. Now, let's talk about the situation where create a non-cluster index. So what happens in that situation? Now, if we are creating a non-cluster index, and if your option sort in tempdb is set to on, then there must be sufficient free space available in tempdb, because this option is turned on, so sort runs will get stored in the temporary database. So at that time, sufficient space should be available in tempdb. In the case of non-cluster indexes, sufficient space should be available in tempdb to store the sort runs. So that is the requirement. And also, in addition to that, sufficient free spaces should be available in the destination file group to store the final index structure. So at both the destination file group and the tempdb, the space is required. In tempdb, space is required to store the sort runs, and in the destination file group, space is required to store the final index structure. The sort runs basically contain the lead rows of the index. So sort run basically contain the rows which is required for the index building. And second thing is, if you are creating a non-cluster index and if your sort and tempdb option is set to off, in those cases, the free space is only required in the destination file group, and the free space should be large enough to store the final index structure. Now, let's talk about the situation where when you create a cluster index on a table that does not have any non-cluster indexes. So in this situation, we only have a single cluster index present on a table, and no other non-cluster indexes are there. If in that situation, if also the sort in tempdb option is set to on, we need to make sure that there must be sufficient free disk space available in the tempdb to store the sort runs. This is a requirement. And basically, these includes the data rows of the table. All right, so in tempdb, the result of sort runs will get stored, and this sort runs will include the data rows basically as well of the table, the data rows of the table as well. And we should have enough space to hold these data rows, and there must be sufficient free space available in the destination file group as well to store the final index structure. So in both the locations, space should be available. In the destination file group, the space should be available to store the final index structure, and in tempdb to store any sort runs. And these sort runs include the data rows of the table as well. This includes the data rows of the table and the index B tree structure. Now, if your sort and tempdb option is set to off, we should have enough free space in the destination file group, and this free space should be large enough to store the final table. All right, and along with the final table, this will also include the index structure as well. And in the case sort in tempdb option is set to off, the free space in destination file group must be large enough to store the final table and any associated index structure as well. Now, when we create a cluster index on a table that has non-cluster indexes, now we are talking about the situation where we have non-cluster indexes present along with the cluster indexes. And if in those cases, if the sort and tempdb option is set to on, then there must be sufficient free space available in the tempdb to store the collection of sort runs for each of the cluster and non-cluster indexes. So tempdb should have sufficient space to store the collection of sort runs for the largest index. So in that case, it will consider the larger index. So tempdb should have that much space available to store the sort run for the largest index, and which is basically typically a cluster index is the largest index in the table. And it should also have sufficient space in the destination file group to store the final structure of all the indexes, including any cluster and non-cluster indexes. So in the final destination file group, it should have sufficient space to store the final structure of all the indexes, and this also includes the cluster index and contain the data rows of the table as well. Now, if a sort in tempdb is set to off, in this scenario where we have cluster and non-cluster both indexes are present, and if we have this option set to off, then we need to make sure that we have sufficient free space available in the destination file group. And this space must be large enough to store the final table for the cluster index. And this includes the structure of all the indexes. So the destination file group will hold both the final table as well as all the structure of all the indexes present. So guys, we are done with this video. I hope you like this video. If not, I would highly recommend you to go through this video again and read through the notes once again to get a better grasp. So we are done here. Today we have discussed about the sort and tempdb option for indexes, and we have talked about the phases of index building. The index building happens in two phases, and we talked that in first page the database scanning is done and the index leaf rows are written, and in the second phase index leaf rows are read, and finally the index is written, index structure is written. So this is a two-phase process which basically constitutes the phases of index building. And we have talked about the scenario where we are building an index, and when you are keeping this option sort in tempdb on or off, what happens during that scenario in the cases where we are creating a cluster index, non-cluster index, or both. We have talked about all the scenarios here. So I hope you got the ideas presented in this video. If not, please go through the video again. Now let me come back to the slide. Guys, if you like this video, if you really like this video, please click on the like button below this video. And also guys, if you're new to this channel, if you haven't yet subscribed to the channel, please go ahead and do so. There's a subscribe button below this video. Click on that subscribe button. It will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding all my future videos. And guys, if you have good network of friends, please ask them to join my channel or subscribe to my channel if they work in SQL Server domain. And you may also share my videos with them. I thank you so much for your time on this video today, guys, and you have a wonderful day ahead. Thank you.